In this video, we will discuss how to perform operations with complex numbers. Complex numbers are numbers that both have a real and an imaginary part. And as we discussed earlier, imaginary numbers come when we try and take square roots even roots of negative numbers. So complex numbers have a real and an imaginary part, and you can add, subtract, multiply, and divide them just like you can with normal numbers. As I already said, a complex number has a real and an imaginary part. The real part is always listed first, and the imaginary part is always listed second. And the imaginary part's easy to tell because it has the little I on it, which stands for imaginary. So when you have a real part plus an imaginary part, that is a complex number. Adding complex numbers is very similar to adding variables and constants. For instance, if I were to take 4 minus x and add to it 3 plus 2x, all I would do is I would add the like terms. So you would do 4 plus 3 and get 7, and you'd do negative x plus 2x and get 1x. So the same thing is going to be done when we add or subtract complex numbers. If I want to add these bottom two here, 4 minus I plus 3 plus 2I, you would take the real parts and add them. So 4 plus 3 is 7. And then you take the negative I and add to it the plus 2I. And negative 1I plus 2I would be 1I. So this would be the real part, and that would be the imaginary part. So adding them is very similar to adding variables. If you are asked to subtract complex numbers, the thing you need to remember is that you need to subtract both the real part and the imaginary part. So you kind of have to distribute that minus sign. So this would be 7 minus 5i, and then you'd have minus 1 and plus 5i. So now if I combine my like terms, the real parts, 7 and negative 1 make 6, and negative 5i and positive 5i just cancel each other out. So the answer is just 6. So it is possible that the imaginary part gets canceled off when you add or subtract complex numbers. The other thing that we will look at is multiplying complex numbers. So if you were to take 5i and multiply it by negative 2 plus I, it's very similar to distribution. You take the 5i times both of these. So 5i times negative 2 would be negative 10i. 5i times I would be 5i squared. Now, usually you'd be done here, but there is a property of complex numbers that says that I squared equals negative 1. And that's something you're going to have memorized, that I squared is the same as negative 1. So here, I could replace I squared with negative 1. So it's not 5 times I squared, it's 5 times negative 1, which is negative 5. So the answer here would not be this, because the real part always needs to be written first. So you'd have to flip-flop the order. The answer would be negative 5 and minus 10i. Here's another example of multiplying complex numbers. Again, it's very similar to variables. You can really sort of think of I as just being a variable, so here I would FOIL this out. First, outer, inner, last. So the first, negative 2 times 6 is negative 12. Negative 2 times negative 2i would be positive 4i. 3i times 6 would be 18i. And 3i times negative 2i would be negative 6i squared. So, I can combine the middle terms, but I also have to remember that this is like negative 1. So on my next line here, I'd have negative 12, 4i and 18i is 22i, and then this is really negative 6 times negative 1, which is positive 6. And so now I have some more like terms. Negative 12 plus 6 is negative 6. So, negative 6 plus 22i would be the answer. Looking at one more example, these are called conjugates. The first and the second one here are called conjugates. So what that means is that they are the same except for one is addition in the middle and one is subtraction. And I want to show you what happens whenever you multiply conjugates. So again, it's going to be FOIL. So you would have 6 times 6, which is 36. You would have 6 times negative 3i, and you'd have 6 times positive 3i. Oops, I made a mistake there. 6 times negative 3i would be negative 18i. Negative 18i. And this would be positive 18i. And then 3i times negative 3i would be negative 9i squared. So what happens with conjugates is that these middle terms will always cancel each other out. A negative 18i plus an 18i. And then remember, this is negative 1, so it's like negative 9 times negative 1. So you're really just left with 36 and positive 9 for 45. So the property that you need to know about conjugates is that they will always cancel the imaginary parts out. Conjugate complex numbers multiplied to give you a real number. There is no imaginary part when you multiply conjugates.